Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about carbonyl compounds lecture 3. So this will be highly beneficial for BSc chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus under CC6 paper semester 3 unit 3 carbonyl compounds. Today we are going to talk about mechanisms of Aldol reaction, Benzoin condensation reaction, Neuville condensation reaction, Perkin reaction and Cannizzaro reaction. So this is the prerequisite knowledge you must have. So usually the reactant is converted to the product with the help of reagents. So how that reactant is converted to the product with the help of reagents, so that is the mechanism. So the mechanism shows the movement of double-headed arrow, how bonds are broken and new bonds are formed leading to formation of product, which may be multi-step or one-step process. So usually the bond is represented like this. So when this bond is broken heterolytically, on which atom it breaks, that gets negative charge with both the electrons, so that we call nucleophile, and other atom electronically deficient, A+. So that is electrophile. And usually the nucleophile always attack to the electrophile, giving rise to nucleophile-electrophile bond. So these are the topics we are going to discuss. So let's start with mechanism of aldol condensation. So question arises, what is aldol condensation? Aldehyde or ketone react in presence of dilute OH- ion to give rise to beta hydroxyaldehyde or ketone is known as aldol condensation. So if you start with 2 equivalent of acetaldehyde and you have to react that with dilute OH- ion, sodium hydroxide, let's say. So you will end up with this beta hydroxyaldehyde, that is known as butyraldehyde. So this is the CHO group. So with respect to this is alpha carbon and this is beta carbon. So that's why this is beta hydroxyaldehyde. Similarly, if you start with 2 equivalent of acetone, you will end up with this 4-hydroxy 4-methyl pentane 2-one. So with respect to this keto group, so this is alpha and this carbon is beta. So you get beta hydroxy ketone. Now let's talk about mechanism. So first step is formation of a resonance stabilized carbanion, that is nucleophile. So CH3CHO, that we can write like this. So again OH- will take this proton and this CH bond will break on carbon. So you get CH2 minus CHO. So this is the carbanion and this is resonance stabilized. So next step is nucleophilic addition of carbanion to aldehyde or ketone. So once you generate this carbanion, so it will act as a nucleophile. This CH2 minus will attack this carbonyl carbon and C double bond O will break on oxygen. So as a result, you will end up with this oxyanion. And this O minus will take proton from water, giving rise to the beta hydroxy product. Similarly, aldehyde and ketone, they can undergo in reaction in presence of dilute OH- ion, giving rise to crossed aldol condensation reaction, that is beta hydroxy ketone. And if you heat this, it will lose 1 molecule of water, you can get unsaturated ketone. So please write down the mechanism for this one. So this is the homework for you guys. Similarly, this aldol condensation can react in presence of acid catalyst. So let's start with this aldehyde. So oxygen lone pair. When this is benzaldehyde, so oxygen lone pair will take the will attack to the proton. So you get OH plus, and this C double bond OH plus will break on O plus. So as a result, you generate a carbocation. And this, if you start with this acetone, so that can undergo enolization, giving rise to this enol. So this enol can act as nucleophile here, and this carbocation will act as electrophile. So the nucleophile will always attack to the electrophile in this fashion. So as a result, you end up with this protonated species and loss of proton, giving rise to this hydroxy compound. And again, if you heat this compound, So this oxygen lone pair will attack to proton and it will eliminate one molecule of water. You will get alpha beta unsaturated keto compound. Then next is benzoin condensation. So what is benzoin condensation? Aromatic aldehydes undergo self condensation of two molecules of itself in presence of cyanide ion, giving rise to benzoin. So if you start with benzaldehyde, two equivalent, so in presence of a potassium cyanide, cation or cyanide minus ion, you end up with this benzoin. So what is the mechanism? So Cn minus can act as nucleophile, it will attack to carbonyl carbon, and C double bond will break on oxygen. So you end up with this tetrahedral intermediate. So here rapid proton exchange will take place. So you generate a carbanion here. So once you generate the carbanion, it will react with another molecule of benzaldehyde. So C minus will attack this carbonyl carbon and C double bond O will break on oxygen. So you end up with this intermediate. Again the proton exchange takes place. So once you generate this O minus will come back and it will kick out Cn as Cn minus. So you will end up with the product benzoin. The next is Knoevenagel condensation reaction. So the condensation reaction between an aldehyde or ketone with a compound having an active methylene group in presence of a base and often a catalytic amount of carboxylic acid to yield an unsaturated compound is usually known as Knoevenagel condensation reaction. So this is the aldehyde here we have taken and this is the active methylene compound, malonic acid. So this CS2 here, this is the active methylene group which is flanked by two electron withdrawing groups, CO group or COH group. So in presence of pyridine, so you will end up with this dicarboxylic acid and it will loses one molecule of carbon dioxide giving rise to crotonic acid. So let's talk about the mechanism how this crotonic acid is formed. So first step is reaction of base with active methylene compound give rise to carbanion. So pyridine is the base, so it will take the proton, this acidic proton, so you generate a carbanion. So this CH bond will break on this carbon. So you as a result you generate this CH minus, malonic acid carbanion and the protonated pyridine. Second step, the carbanion attacks to aldehyde compound. So this CH minus will attack this carbonyl carbon and C double bond O will break on oxygen. So you generate this oxyanion, so it will take the proton again from protonated pyridine and this AHN bond will break on N plus. So you get this hydroxy compound, hydroxy dicarboxylic compound. So again pyridine takes this proton and this bond will come here and it will kick out OH as OH minus. So as a result you end up with this unsaturated compound and upon heating it will lose one molecule of carbon dioxide in this fashion. So as a result you get crotonic acid. The next is Perkin reaction. So what is Perkin reaction? When benzaldehyde is heated with acetic anhydride in presence of sodium acetate catalyst, a condensation reaction takes place leading to formation of alpha beta unsaturated acid. This reaction is known as Perkin reaction. So if you start with benzaldehyde and you give the reagents acetic anhydride and sodium acetate, you will end up with the product cinnamic acid and acetic acid. So let's talk about how this benzaldehyde is converted to cinnamic acid. So first step is the reaction of acetate ion with acetic anhydride gives rise to carbanion, that is the nucleophile. So sodium acetate that gives rise to CH3CO minus and Na plus. So this CH3CO minus will take the proton from this CH3 and CH bond will break on C carbon. So you get this carbanium plus acetic acid. And this carbanion can be also resonance stabilized. Then second step, the reaction of carbanion nucleophile with benzaldehyde. So this carbanion will C minus will attack this carbonyl carbon and C double bond O will break on oxygen, giving rise to O minus in this product. So again it will take O minus will take the proton from acetic acid, giving rise to this hydroxy product. So once you get this hydroxy product, so you can heat, so it will lose one molecule of water. so giving rise to this unsaturated compound. So again further hydrolysis of this anhydride giving rise to this cinnamic acid and acetic acid. The next is Cannizzaro reaction. So aldehydes with no alpha hydrogen atom, when treated with concentrated alkali or other strong bases, undergo self-oxidation and reduction to produce an alcohol and salt of carboxylic acid. So this disproportionation reaction is called Cannizzaro reaction. So if you take two molecules or two equivalent of formaldehyde and you react with concentrated OH minus ion, so this would give rise to CH3OH and HCONA. So what is the mechanism? How this formaldehyde is converted to methanol and HCONA. So first step is reversible addition of OH minus ion to give anion. So OH minus ion can act as nucleophile. It will attack to carbonyl carbon and C double bond O will break on oxygen. So you get this tetrahedral intermediate. So in this step, the hydride ion transfer to another molecule of aldehyde. So this oxyanion molecule will react with another molecule of aldehyde. So when this O minus will come back, it will transfer H as H minus. So H minus attacking to this carbonyl carbon and C double bond O will break on oxygen, giving rise to this carboxylic acid plus CH3O minus. So in next step, the proton exchange takes place, which is a very fast step. So giving rise to HCO Na minus, so HCO minus Na plus CH3OH. And this Cannizzaro reaction can also take place intramolecularly. So 1,2-dialdehydes or alpha ketoaldehydes can undergo intramolecular Cannizzaro reaction. So if you start with this diketo compound in presence of concentrated OH minus ion, you will end up with this product. Similarly, you start with glyoxal, so you will end up with glycolic acid. So let's see what is the mechanism. So if you start with this diketo compound, so H minus will attack this carbonyl carbon and C double bond O will break on oxygen. So once you end up with this oxyanion complex, so when O minus will come back, so this H will be transferred as H minus and C double bond O will break on oxygen. So you get this oxyanion and it will transfer the proton exchange. So from O minus will take this proton, you get this hydroxyl group and CO minus. So this CO minus Na plus. So if you start with this compound plus formaldehyde in presence of OH minus ion, you should get these two products. But the thing is, the Cannizzaro reaction fails due to steric hindrance. So here you have three bulky groups. Okay, so the Cannizzaro reaction does not take place. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveuGPG.com. For 11th and 12th class student, this is the YouTube channel Foundation Chemistry AB. This is also available in the website foundationchemistryab.com. So this is a simple step towards e-learning, making life better. Thank you all for learning.